Hello students, welcome. Today we want to do KCSE 2025 Chemistry Predictions. The code for chemistry is 233, and remember chemistry has 3 papers: chemistry paper 1, chemistry paper 2, and chemistry paper 3. So both chemistry paper 1 and chemistry paper 2 are theory papers, while chemistry paper 3 is a practical paper. So today we are going to start with the chemistry paper 1, which is a theory paper, and this prediction is October 2025, and we are going to start with the first paper 1 series. So we are going to do maybe 2 to 3 series. This is the first series. Kindly stay with us until the end of the video. So next, these are the instructions given to the student, and the number of questions for this paper is 31 questions, and the total marks for chemistry paper 1 is 80 marks. So there, candidates score, we are going to record the number of marks that the student got out of 80. Now let's go to the first question. The first question, we are told the table below gives the atomic numbers of elements A, B, C, and D, and we are told the letters do not represent the actual symbols of the elements. So we are having elements A, B, C, D, atomic number 9, 10, 11, and also 12. So part A of question 1, we are told which of the elements is unreactive. Then we are told to explain. So when we are told which element is unreactive, they are referring to the noble gases. So out of these 4 elements, which one is a member of the noble gases? So for us to know that, we have to write the electronic configuration. So the electronic configuration for A is 27, the one for B is 28, the one for C is 281, and the one for D is 282. So that means element B is a group 8 element. So the answer is B. What is the reason? Because we are supposed to explain. So we are going to say because it has a stable electronic configuration. Remember we said a stable electronic configuration include 2, 28, and 288. So these elements having 28, so that means it has a stable electronic configuration. Or we can say it is outermost energy level is filled with electrons, that is 8 electrons. That means it cannot carry more electrons. But B, we are told which 2 elements will react most vigorously with each other. Like when you ask this question, they mean select the most reactive metal and the most reactive non-metal. So when we are talking about the most reactive metal, we get from alkali metals. So what are alkali metals? They are group 1 elements in the periodic table. So that means one of them is C, because C is having an electronic configuration of 281. So the most reactive non-metal is found on the halogens. So what are halogens? Group 7 elements. So that means the other element is A. So the 2 elements that they were talking about was C and A. If you can write A and C, you are still correct. So but C, we are told give the formula of the compound formed when elements in B above react. So when we are writing formulas of compound, we say first of all we have to know the valency of the elements forming the compound. So that means the valency of C is 1 and the valency of A is also 1, because A, for it to become stable, it gains 1 electron. So remember we said valency is the number of electrons that an atom gains or loses to become stable. So both of them, they're having a valence of 1, so that means we are going to write it like C like that, because we don't write 1. So learners, these are the answers for question number 1. We are going to proceed to question number 2. So in question 2, we are told a clean sample of steel wool was placed in a test tube containing some water droplets and the test tube is inverted over a trough of water, then we are told after 3 days, the volume of air in the test tube changed from 20 centimeter cube to 16 centimeter cube, and a brown layer, that's rust, formed on the steel wool. Part A of the question, we are told, write a chemical equation leading to the formation of the brown layer. So when we are dealing with the rusting, first of all, we are supposed to have the metal, that is iron. So we are going to have iron plus. Then next we need oxygen, that is air or oxygen. So we are going to have iron plus oxygen plus again water, because rusting cannot take place in the absence of water. Even we have learned the conditions necessary for rusting, that is oxygen and also water. But we have to get also the metal. So when the three react, what we are going to get is the formula for rust, which is hydrated iron 3 oxide. So to write the formula, it will be 4 moles of iron, 4 moles of iron reacting with 3 moles of oxygen gas, plus reacting with the 2 moles of water, which is liquid. What we are going to get there is 2 moles of hydrated iron 3 oxide. Hydrated iron 3 oxide. So part B. Part B, we are told a little of the brown solid was dissolved in nitric 5 acid and dilute potassium hydroxide or even sodium hydroxide added dropwise until in excess. So we are told write an ionic equation to justify this statement or the observation made, 1 mark. So what will happen when this roast, this hydrated iron 3 oxide is dissolved in nitric 5 acid? So you're going to get iron 3 nitrate plus water. So that iron 3 nitrate contains iron 3 ion, because remember we said all nitrates are soluble. So we're having iron 3 ions there. Ions are aqueous plus. So when they're reacting with the potassium hydroxide, we have hydroxide ions there, hydroxide ions, which will react with this iron 3 ions, and what we are going to get is iron 3 hydroxide, which is a brown precipitate, iron 3 hydroxide, a brown precipitate. We are supposed to balance this equation. We have 3 hydroxides, we have to put 3 there, and the equation is balanced like that. So part C, we are told state one main disadvantage of the process leading to the formation of the brown layer. They are asking us the disadvantage of rusting, and number 1, we can say it destroys tools or equipments or even machinery. That is the disadvantage of rusting. So these are the answers for question number 2. We are going to proceed to question number 3. So question number 3, we are told equal volumes of 2 molar monobasic acids R and S were each reacted with excess magnesium ribbon. The table below shows the volume of the gas produced after 1 minute. So we're having the acid R and S, volume of gas in centimeter cube. We are going to get 8 centimeter cube and also 30 centimeter cube. Obviously, the gas we are talking about is hydrogen gas, because when a metal reacts with an acid, what we are going to get is salt and hydrogen gas. So part A, we are told write the ionic equation for the reaction taking place. So when we're asked to write ionic equation, we can write the ionic equation, or first of all, let me write the long equation so that you understand. So we're having there magnesium, which is solid, reacting with a monobasic acid. Let's say, for example, hydrochloric acid. An example of monobasic acid include hydrochloric acid and nitric 5 acid. All acids are aqueous. Then what we are going to get is magnesium chloride, which is our salt, plus hydrogen gas. That is the equation. We want to write the ionic equation. For us to write the ionic equation, first of all, the ones that are aqueous, we are going to separate them into ions, like hydrogen ions and also chloride ions. This one is also aqueous. We have to put it magnesium ion to chloride ion, so it will be 2 of chloride ions like that. This gases and this solid, we leave it the way it is. So what we are supposed to do, first of all, let's balance the equation. Then next, you remove the ions that we see on the reactant side. So what is coming back is 2 of chloride ions here, which is aqueous. Then we have 2 of chloride ions there. So we cancel. These 2 chloride ions will go with those 2 chloride ions. So what will remain is what we are going to write as the ionic equation. So what we are going to have is magnesium solid. We are going to have magnesium solid plus we're having 2 of hydrogen ion, aqueous. All ions are aqueous. Then aero, we are going to have magnesium ion, aqueous. Then we are going to have plus hydrogen gas. That is the ionic equation. That's how we write the ionic equation. So part B, we are to explain the difference in the volume of the gas produced. Obviously here they are testing, or they are asking us which of these two is strong acid and which one is a weak acid. So the one that produces more volume is the one for the strong acid. So we are going to say R produces more volume of the gas compared to S, or than S. Reason? Because R is a strong acid, hence fully dissociate or fully ionize, producing more hydrogen ions, which will react with the magnesium ions to form more volume of the gas. While S is for a weak acid, therefore it partially dissociates to produce few hydrogen ions, which will produce, or which will react with magnesium ion, producing less volume of the gas. That's the explanation. So these are the answers for question number 3. We are going to proceed to question number 4. So in question number 4, we are told nitrogen peroxide and dinitrogen tetraoxide gases exist in equilibrium at 20 degrees Celsius according to the equation below. So the equation is here, and the color for that dinitrogen tetraoxide is pale yellow, while the one for nitrogen peroxide is brown. So we are told state and explain the observation that will be made when part A, a syringe containing the mixture is heated to 40 degrees Celsius. So what have they done here? What they have done was they have increased the temperature, because the initial temperature was 20 degrees Celsius. So what is the effect of increasing temperature in a reaction at the state of equilibrium? What will happen? Because this is an equilibrium equation. So what will happen is that the equilibrium will shift to the endothermic direction of the reaction. What does endothermic means? Here, when we are writing the equation like this equation in a forward reaction, it is exothermic because of the negative. But the opposite of that is endothermic. That means backward reaction is an endothermic reaction. So that means pale yellow color of the mixture will be intensified. That's the first of all the observation. What about the explanation? We are going to say increase in temperature favors endothermic direction of the reaction, hence backward reaction is favored. That is the answer. We are going to proceed to part B. We are told the gaseous mixture is compressed. What does compressed mean? That means we are increasing the pressure. We are increasing the pressure. So what will be the effect of increasing pressure in this equilibrium equation or reaction? So when we are talking about pressure, we check the moles or the volume of the gases on both sides. Here we have 1 mole and here we have 2 mole. So what does increase? Where does increase in pressure favors? It favors the side with few moles or molecules or volume. So in our case, it is this side of dinitrogen tetraoxide. So that means again the observation will be pale yellow color of the mixture will intensify. The reason is we are going to say increasing pressure favors the side with few moles or molecules or volume of the gases. Hence, backward reaction is favored. So we're done with question number 4. So learners, those are the answers for question number 4. We are going to proceed to question number 5. So let's proceed to question number 5. Part A, we are to use an equation to explain the acidic nature of an aqueous solution of silicon 4 chloride. So that means when we are going to have silicon 4 chloride liquid, when they are hydrolyzed with water, that means 2 moles of water, they are going to form acidic solution. So that means we are going to get silicon 4 oxide, which is solid, plus 4 moles of hydrochloric acid, aqueous. So that is the question that we are supposed to write. Part B, we are told name another metallic chloride which behaves like silicon 4 chloride. So it's aluminum chloride. So we're going to have the aluminum chloride. We are going to write it in full. So learners, those are the answers for question number 5. We are going to proceed to question number 6. So in question number 6, we are told explain why an organic compound with formula C3H6 burns with a more sooty flame than C3H8. So when we see these two organic compounds, first of all, they are hydrocarbons because they consist of carbon and hydrogen atoms only. This one is for an alkene because the general formula for alkene is CnH2n. Then this one is for an alkene, that's CnH2n plus 2. That's their general formula. So that means alkenes are unsaturated hydrocarbon while alkane are saturated hydrocarbon. So what we are going to say is that C3H6 is unsaturated hydrocarbon. That means they are going to have a higher carbon to hydrogen ratio than the one for alkane. That is C3H8. Question number 7. We are told when reacting sulfur peroxide and hydrogen sulfide, some traces of water vapor is required for the reaction to occur. Part A, we are told state the role of water vapor. So water vapor acts as a catalyst. That is its role. Part B, we are told write an equation for the reaction that occurs. So when sulfur peroxide reacts with hydrogen sulfide, that means sulfur peroxide will be reduced to sulfur while hydrogen sulfide will be oxidized to sulfur and water. So that means the question we are going to talk about there is sulfur peroxide plus 2 moles of hydrogen sulfide giving us sulfur plus 2 moles of water. Don't forget to write the states. This is a gas. This is also a gas. So part C, we are told identify the reducing agent in the reaction in B above. Explain. So here we are having the reducing agent. That's what we are asked to get. So the reducing agent is hydrogen sulfide, and the reason is that it reduces sulfur peroxide into sulfur while itself gets oxidized to sulfur and also water. So learners, these are the answers for question number 6 and also question number 7. So now let's proceed to question number 8. So in question number 8, part A, we are told nitrogen 1 oxide supports combustion of burning charcoal. Write an equation for this reaction. First of all, let's know what will happen when nitrogen 1 oxide reacts with charcoal. A charcoal is carbon. What we are going to get is nitrogen gas and also carbon 2 oxide. So the reaction will be 2 moles of nitrogen 1 oxide, which is a gas, reacting with charcoal, that is carbon. What we are going to get is that nitrogen gas plus carbon 2 oxide, which is a gas. So in this reaction, carbon is acting as a reducing agent because it reduces nitrogen 1 oxide into nitrogen while itself gets oxidized to carbon 2 oxide. So part B, we are told ammonium nitrate can be heated to give off nitrogen 1 oxide. However, a mixture of ammonium chloride and sodium nitrate is preferred. We are told to give a reason or explain. So here, when ammonium nitrate is heated directly, it may explode. But when it is in a mixture, it does not explode. That is the reason why they prefer in that mixture. So part C, we are told to state the physical taste on nitrogen 1 oxide. Remember, nitrogen 1 oxide has a pleasant smell. That is, it is physical taste. Like if they could have 2 layers, what is the physical taste for hydrogen sulfide gas? You could have said it has the smell of a rotten egg. So learners, these are the answers for question number 8. We are going to proceed to question number 9. So in question number 9, we are told metals Q and T had their half cells connected to zinc half cell, and the following reduction potentials were obtained from each metal. So part A, we are told what name is given to zinc half cell in this circumstance and predict its reduction potential. So it is refers to as the reference electrode, that is, it is name given. Then, being the reference electrode, it will be assigned to an electrode potential of 0.00 volts. We can write volts in a V like that, or we can write in like volts. So part B, we are told metal Q and T were connected to form an electrochemical cell. Then we are told write the question for the half cell reaction that occur at Q. So let's talk about first of all Q. The metal Q is this one here, and its reduction potential is negative 1.37, but the other one for T is negative 0.83. So that means it has more negative. That means it acts as the reducing agent. So if it is the reducing agent, so it is supposed to lose electrons because it undergoes oxidation. What's oxidation? Loss of electrons. So we are going to have first of all the Q in its solid form, then loses electrons. When we are losing electrons, those electrons are written on the product side. So we are going to have Q2 plus aqueous plus 2 electrons. So we proceed to part C. We have to calculate the EMF of the electrochemical cell above. So we have the formula. If I want to get the standard electrical potential value of a cell, or the EMF of a cell, the formula is that we are supposed to have E reduction means E oxidation. So when we are talking about E reduction, it will be the one with less volts. That's negative 0.83. Then we are going to say negative 0.83 minus, then another minus 1.37. So there, what we are going to get will be positive 0.54 volts. So we are going to get positive 0.54 volts. That is our answer. So these are the answers for question number 9, part A, part B, and also part C. So in part C, this is the formula that we are talking about. So the E reduction side, we are having negative 0.83 because it is the oxidizing agent in our case, then minus the E oxidation for the reducing agent. So it will be negative 1.37. So when we put these values in the calculator, we are going to get positive 0.54 volts. We proceed to question number 10. So question number 10, we are told based on kinetic theory of matter, explain why part A, a solid has a definite shape while a gas does not. Remember, when we are talking about the kinetic theory of matter, we said the particles of solids are closely packed together, while those for the liquids, they are closely packed. They are not so closely like those of the solid state, but the ones for the gases, we said they are widely separated. That means they are very far from each other. So when we are told a solid has a definite shape, is that because the particles are closely packed, while a gas, the particles are very far from each other. That's the reason. Part B, we are told the temperature of ice rises up to 0 degrees Celsius when heated and then remains constant at 0 degrees Celsius. So that means at 0 degrees Celsius, if we further heat it, the heat absorbed will be used to only weaken the force of attraction holding the solid particle, that's the ice in our case, together, but it will not raise the melting point of that ice. So learners, these are the answers for question number 10. We are going to proceed to question number 11. So in question number 11, we are told a certain carbonate, that is XCO3, reacts with dilute hydrochloric acid according to the question below. We have the question there. And we are told if 4 grams of the carbonate reacts completely with 40 centimeter cube of 2 molar hydrochloric acid, calculate the relative atomic mass of X. And we are given the relative atomic mass of carbon, oxygen, and also chlorine. So in this question, we have the standard solution as the hydrochloric acid because we know it is volume and also we know it is molarity. So first of all, we are supposed to get the number of moles of the standard solution, that's the hydrochloric acid. So our analyte will be the X-carbonate. So when we get the number of moles, next step, we have to use the mole ratio to get the number of moles of the X-carbonate. Next, we can find out the relative formula mass of the X-carbonate. Then from there, we get the relative atomic mass of X. So learners, these are the answers for question number 11. First of all, we have to get the number of moles of hydrochloric acid as it is the standard solution. Number of moles is gotten by the formula molarity times volume used over 1000. So the molarity is 2, the volume is 40 divided by 1000. There we are going to get 0.08 moles. Next, we have to get the number of moles of the X-carbonate by using mole ratio. So from here, the mole ratio is 1:2. So we have the number of moles of the hydrochloric acid, it is 0.08. So we ask ourselves, what about the one for X-carbonate? So it will be 1 times 0.08 divided by 2. We get 0.04 moles. So if we have moles and we have mass here, can we get molar mass? Yes. RFM is gotten by mass divided by moles. So the mass is 4 divided by moles, which is 0.04. We are going to get 100. So that means the RFM for this compound is 100. And how is RFM obtained? By adding the relative atomic mass of the atoms forming the compound. So we're having X, which is unknown, plus 12 for carbon, plus 16 times 3 for oxygen will be equal to 100. So X plus, when we add this, we get 60, it will be equal to 100. So X will be 100 minus 60, therefore X will be 40. If we are asked to state the identity of element X, it will be for calcium because the relative atomic mass of calcium is 40. Let's proceed to question number 12. So in question number 12, we are told using dots and cross diagrams to represent electrons, show bonding in the compounds below. So we are given the atomic numbers of aluminum, chlorine, and also oxygen. So part A, we are told aluminum hexachloride, which can be written Al2Cl6. So the other name for this compound was aluminum chloride dimer. So here we're having two aluminum. First of all, remember, dimer aluminum chloride is having covalent bond, not ionic bond. You may say aluminum is a metal and chlorine is non-metal. So the type of bonding that we have there is ionic bonding. No, it's covalent bonding. So we're going to have two aluminum, one on this side and the other one on the other side. So we're having each aluminum is bonded to 3 chloride ions, out of which one is having dative bond with the other aluminum. So let's proceed to part B, aluminum oxide. Aluminum oxide is having now ionic bonding because we are having aluminum being metal and oxygen being non-metal. So we are going to check the diagram. So this is 12 part A, that aluminum chloride dimer. We're having the two aluminum here. Each aluminum is going to have 3 chlorine, 1, 2, and 3. This is the other aluminum, it's having 1, 2, 3. But out of these 3, one of them must form coordinate bond or dative bond with the other aluminum. The one for the other aluminum, it's having 3 chlorine. One of it must form a coordinate bond with this aluminum. If we open this structure, it is supposed to be like this. So we are having here up there chlorine, chlorine, and also chlorine. The other aluminum is here. We are having chlorine, chlorine, and chlorine. So the dative bond will come from that chlorine going to this aluminum, and the other one from this chlorine to that aluminum. So we are having two dative bonds, they are coordinate bond. One of them is for this chlorine because it is in this with the covalent bond, and this for coordinate bond. Check, it is 2 dots here. For this other chlorine, it is here. This chlorine, it's forming covalent bond with this aluminum, that is X cross the way you see, but it's forming coordinate bond when we talk about this other aluminum. That's why you see the 2 dots there. Let's proceed to aluminum oxide. Here, it's ionic bonding. So we're supposed to know the ion of aluminum. Aluminum is having an atomic number of 13, so it will lose the 3 electron. We are going to get 10 electrons. So this is 2, then 8. We close, it has lost 3 electrons. So we have in 2 there, we put the 2 here. Then the other one is oxide. Then that means oxide, first of all, is in number 8, so it has to gain 2 electrons to become stable. So it's having 10. So 2, then it was having 6 dots initially, then it has gained these 2 crosses from aluminum. We close and we say it has gained 2 electrons. Then how many oxygen or oxide do we have there? 3. We put the 3 there. We are going to proceed to the next question. Question number 13, part A. We are told state Graham's law of diffusion. So we can say under the same condition of temperature and pressure, the rate of diffusion of a gas is inversely proportional to the square root of its density. That's what we can say as our answer. So learners, we have question number 13, part A, the answers for and part B. So let's explain part B. So part B here, we are told 20 centimeter cube of a known gas Q takes 12.6 centimeter. So part B of question 13, we are told 20 centimeter cube of a known gas Q takes 12.6 seconds to pass through a small orifice. 10 centimeter cube of oxygen gas takes 11.2 seconds to diffuse through the same orifice under the same conditions of temperature and pressure. We are asked to calculate the molecular mass of the unknown gas Q. Here, this question we can do it using 2 methods. The first method, we are supposed to calculate the rates. So the rate of Q rate is obtained by volume divided by time according to this equation. According to this question. So what we are going to get is 1.5873 centimeter cube per second. What about the rate of oxygen gas? We are going to have the volume as 10 divided by 11.2. We are going to get 0.8923 centimeter cube per second. Then we relate rate with the molecular mass. The rate is that rate is inversely proportional to the square root of the molecular mass. That's why the rate of oxygen is inversely to the square root of the molecular mass of oxygen. You see that of Q inversely proportional like that. So let's insert the values. The values for the rate of oxygen, the rate of oxygen is down here, is 0.8929 divided by the one for Q, which is up there, will be equal to the relative molecular mass of Q, we don't know. We are going to write X divided by 32. Why is 32 for oxygen? Because it's 16 times 2. Oxygen exists as a diatomic molecule. So square root. So for us to remove the square root, we square here, we also square there. So what we are going to get is 0.3164 will be equal to X divided by 32. So to remove this 32, we multiply by 32 here, by 32 there. 32, 32. X will be equal to 10.1248. So we are going to remain with 10. So the other way is that we are supposed to make the two volumes equal. Here we have 20 centimeter cube and here we have 10 centimeter cube of oxygen. So down for oxygen we make it 20. How are we going to make it? We say 10 centimeter cube can give us 11.2 seconds. So we ask us, what about if we make 20 centimeter cube of oxygen? What time are we going to get there? After that, when we make it equal volume, we are supposed to relate time with molecular mass. And the formula there is time is directly proportional to the square root of molecular mass. Then we do the calculation, we get the same answer. So now next let's proceed to question number 14. We are told to describe how a solid sample of copper 2 nitrate can be prepared, starting with copper metal. This question again, we can do 2 ways. The first way, first of all, we can take this copper metal and we react with concentrated nitric 5 acid because we are asked to get copper 2 nitrate. When we take copper metal and we react with concentrated nitric 5 acid, what we are going to get there is copper 2 nitrate plus nitrogen peroxide plus water as our products. The other way is the way for form 2 work, the preparation of salts. There, we're having a metal, copper metal, but cannot react with acid because it is below hydrogen in the reactivity series. So we have to convert this copper metal into other forms like metal oxide. So how can we do that? First of all, we burn or we heat copper metal in air for it to be forming copper 2 oxide, to obtain copper 2 oxide. Then after that, we add excess copper 2 oxide to warm dilute nitric 5 acid. So the acid for this salt is nitric 5 acid. Then what will we do next? We filter to obtain copper 2 nitrate as our filtrate. Then we heat so that we get crystals of copper 2 nitrate after cooling. Then after that, we are supposed to write the questions. The first question, that's the burning of copper in air, and number 2, the copper 2 oxide reacting with the dilute nitric 5 acid. Let's explain in the answer side. So in question number 14, we are told describe how a solid sample of copper 2 nitrate can be prepared starting with copper metal. First of all, we say burn copper metal in air to obtain or to form copper 2 oxide. Then we say add excess copper 2 oxide to warm dilute nitric 5 acid. Then next we filter the mixture to obtain copper 2 nitrate solution as a filtrate and the unreacted copper 2 oxide as a residue. Then thereafter we heat the filtrate to saturation and allow it to cool for crystals to form. Then we dry the crystals between filter papers if purity is required. Thereafter we are supposed to write the two equations. The first equation, copper reacting with oxygen, we are going to get copper 2 oxide, and that equation will be 2 mole of copper solid reacting with oxygen gas, giving us 2 moles of copper 2 oxide, which is solid. So the second equation is that the copper 2 oxide that we have gotten here reacting with dilute nitric 5 acid, and there we are going to get copper 2 nitrate balance water, and also we also balance that equation. So that is for question number 14. So next we are going to proceed to question number 15. We are told when a hydrocarbon fuel burns, one of the main products is acidic gas R. Then we are told identify gas R. So that gas R is carbon dioxide, because when a hydrocarbon burn in air, we get carbon dioxide and water as our products. So the acidic gas they are talking about is carbon dioxide gas. Part B, we are told what two effects does gas R, that carbon dioxide, have when its concentration in the atmosphere exceeds its acceptable level. Number 1, it will cause global warming. That is when it exists, it is exceptional level. Number 2, it also reacts with rainwater to form acid rain, which corrodes the iron sheets, iron gates, making the building dull, kills aquatic lives, that is plants and animals living in water. These are the answers for question number 15. And learners, we are going to stop here. In our next class, we are going to do part 2. We are going to start from question number 16 all the way to question number 31. And this is the end of our class for today. Thank you for watching.